sine inverse, its reciprocal, cosecant inverse, and tangent inverse. Those three exist in quadrant 1 and quadrant 4. Remember, you have a positive quadrant and a negative quadrant, because for an inverse you can only get one answer. Cosine inverse, its reciprocal secant inverse, and cotangent inverse exist in quadrants 1 and 2. This only applies if the original problem has an inverse. So that first page, we are seeing things with an inverse. After that, when we get to solving equations, did any of those equations have an inverse to start with? No. So it does not apply on any of those. It's only if we start with an inverse. So when I look at problem number 1, it says y equals cosecant inverse of negative radical 2. Okay, if you are not comfortable with cosecant, you are welcome to change it to its reciprocal, sine. So that's saying sine is the reciprocal of radical 2. So 1 over radical 2 or radical 2 over 2. When I see cosecant inverse or sine inverse, I know my answer could be in quadrant 1 or quadrant 4, because that is something you have to know, so you will go home and you will look at that tonight and make sure you know it for tomorrow. So then when I'm trying to decide my quadrant, I look right here. This is a negative. So if we're negative, we have to be in quadrant 4. So then, reference angle. When is sine radical 2 over 2? 45 degrees, I think the direction said radians, so pi over 4. If you struggle with knowing these values, tomorrow for the test, you are welcome to take a blank unit circle and fill it out. But you have to be able to fill it out. I won't give you one with everything on it. So then pi over 4 in quadrant 4 is 7 pi over 4. And that's our answer. So number 2. Arc cotangent is the same as cotangent inverse of negative radical 3 over 3. So when I see cotangent inverse, I know that could be quadrant 1 or quadrant 2. Which quadrant is it? Quadrant 2, because it's negative. Okay, reference angle. When is cotangent radical 3 over 3? So cotangent is at 60 degrees or pi over 3. So then pi over 3 in quadrant 2 is 2 pi over 3. Number 3. Arc secant of negative 1.5. So when I see arc secant or secant inverse, that's like cosine, so it could be 1 or 2. It's a negative, so we're in quadrant 2. Reference angle. Do we know when secant is 1.5? No. So remember, you could think of this in terms of cosine. That means cosine is 1 over that. We're going to use the calculator. We talked about how sometimes the calculator will give you the wrong answer, so it's important to only put in the positive when you're doing this. So everybody grab a calculator here. We are in degree mode. And so we need to do, or sorry, not degree, we're in radians. So radian mode, then type in cosine inverse of 1 over 1.5. So my reference angle is 0.8411. We need that to be in quadrant 2. So I've given you this angle. How do you get the entire thing?
180
If we're in degrees, we do 180 minus. Since we're in radians, we do pi minus. So pi minus 0.8411. We get 2.3005. So you'll have a couple like that on your test, just straight working backwards from the inverse. So you have to know your quadrants and work from there. Then the second set of problems on the study guide, you probably have a couple like this where you have a series of things. So we have tangent of arc cosine 3/4. The answer to an inverse is an angle. So what we are being asked to do is find tangent of that angle. I expect exact answers on these, so you can't just plug it in your calculator. You're going to get the wrong answer. When I see arc cosine or cosine inverse, I know that could be quadrant 1 or 2. Which one is it? 1, because the 3/4 is positive. So if we draw our triangle in quadrant 1, cosine is adjacent over hypotenuse. Can I just tell you the third side? Does everybody know how to do Pythagorean theorem to get your missing side? I just want to make sure we get through everything, so I'm just going to tell you. If you do your Pythagorean theorem, that turns out to be radical 7. So now you're being asked to find tangent from this angle. So tangent, opposite over adjacent, so radical 7 over 3.
We did our like triangle different, it doesn't matter, right? I still have to see that. I think this is opposite, that's adjacent.
Technically, since you interpret that way, you answer it. If this is opposite of these triangles, and adjacent is such.
Okay.
All right, so number 5. I asked for sine inverse of tangent pi over 4. All right, this is actually more like problems 1 through 3 because this inside part is not an inverse. This is just tangent of pi over 4. That's like saying, what is the tangent of 45 degrees? 1. So this is sine inverse of 1. I'm asking you, when does sine equal 1? If you think about your unit circle. Sine is the y. So if y is 1, you are at 90 degrees. I did not specify degrees or radians on this, so in radians that's pi over 2. You don't have to have both, one or the other. Do you guys see how problems 4 and 5 were different?
The inverse was big inside.
Exactly. When the inverse is on the inside, that's when we have to do the triangle to get it. Okay, problem 6. We have sine of cosecant inverse of -2. Okay, so the answer to an inverse is an angle. I'm asking you to find sine of that angle. Now technically cosecant inverse -2, you know that. You could answer when cosecant is equal to -2 from the unit circle, or we could set up the triangle if you didn't recognize it. Cosecant inverse could be in quadrants 1 or 4. Which one are we in? 4, because of the negative. So if you didn't catch that it's on the unit circle and you were just in the triangle mode, cosecant is hypotenuse over opposite. The hypotenuse is always positive. So the hypotenuse would be 2, my opposite side would be -1. I'm asking you to find sine of this angle. What's sine? Opposite over hypotenuse, so that's -1 over 2. You could have done Pythagorean theorem and got your other side to be radical 3. We just didn't need it here, so I'm saving time and I didn't find it.
What if we like change cosecant or whatever into sine
And change,
put it into the
so it'd be
triangle?
sine inverse of -1/2.
Yeah.
Yep, and that would work.
Okay.
One more like these, problem number 7. So we have cosine of tangent inverse -1/5. All right, remember the answer to an inverse is an angle. I am asking you to find cosine of that angle. Tangent inverse could be quadrants, what?
1, 2, 4.
1 and 4. Since it's negative, we're in quadrant 4. Tangent is opposite over adjacent. So my opposite side would have to be my negative since it went down. My adjacent would be 5. So Pythagorean theorem. You get this side to be the square root of 26. Does that reduce? No, no perfect squares go into that. So cosine adjacent over hypotenuse. Then you have to get the radical off the bottom, so it's 5 radical 26 over 26. So that's our review from section 6.1. Do you guys have questions on any of those? So if we have more time at the end, we'll come back and do some more problems to review. So next we got into solving equations. And I started out first telling you to do it in degrees. So number 8, we have cosine cubed theta equals cosine theta. What would you have to do to solve this?
Get your cosine theta.
Make sure if you missed them, you're fixing it. Both of these have a cosine, so we could factor that out. So now we set each piece to 0. So cosine equals 0, or cosine squared minus 1 equals 0. Alright. If cosine is 0, so think about your unit circle. Cosine is x. X is 0 here and here. So this would be 90 degrees and 270 degrees. This one, if you add over your 1, square root, you get cosine equals positive or negative 1. So if cosine is 1, that's like saying x is 1, so that's right here at 0 degrees. When x is negative 1, that's right here at 180 degrees. My angle was just theta, not a 2 theta, so we don't have double solutions or anything. So this is it. Those are my only answers.
Can't you write the 0 degrees as 362? Or?
Yeah, technically they are equivalent. In my directions, I put the bracket on the 0 and the parenthesis on the 360. But yes, those are the same thing.
So if we like do that on the test notes.
I might take off a half point just because the directions said to include the 0 and not 360. But it would be minor. Alright, did everybody get that one? Alright, number 9. What do we have to do here? Because we start out with the coefficient of 1, we can do the shortcut box method. So sine squared breaks into sine. What multiplies to negative 3 and adds to negative 2?
3 and negative 3.
So if you set each of those to 0, you get sine to equal 3, and sine equals negative 1. Okay, sine, if you think about your unit circle, sine is the y, and y always has to fall between negative 1 and positive 1. So is it possible for sine to equal 3? Nope, so we just throw that one out. If sine is negative 1 on your unit circle, that's when y is negative 1. So that is 270 degrees. So that is our only answer here. very similar to problem 8. What would you have to do first?
Inverse sine 3 theta.
So I'm just gonna subtract that over so now it equals 0. Then both of them have a sine 3 theta, so we factor that out. Now you have two things multiplied that equal 0, so you set each one of those equal to 0. So, we have sine 3 theta equals 0 and cosine 3 theta equals 1. Alright. When you have that 3 theta, what does that tell us? We have triple solutions. So, it's 3 theta equals. If sine is 0, so on your unit circle, sine is the y, when is y 0? 0 and 180. When is cosine 1? It's positive 1 at 0, negative 1 at 180. But we already have 0, so we don't have to list it again. So these are the only two, but I want triple the solutions. So 2 times 3 tells me we have 6 total. You add 360 to each of these twice. 180 plus 360. And then what do we have to do to all of those? Divide by 3. So theta is 0, 60, 120. Let's see, 540 divided by 3, 180, 70. So those are the answers there. Is that okay? All right. Number 11. And are you guys fixing these if needed? Have we had any major problems so far? So on this one, if I'm just solving for cosine, we can get it by itself. So we subtract over the radical 2, divide by 2. It's cosine theta, so no double or triple solutions. Quadrants, when is cosine negative? Reference angle, when is cosine radical 2 over 2? So, 45 degrees in quadrant 2, 180 minus 45 is 135. In quadrant 3, 180 plus 45, 225. And that's it. Problem 12. We need to get x over 2, or the sine of x over 2 by itself. So first, we have to get them on the same side. So if I subtract this one over, that's 2 sine of x over 2 equals negative radical 3. Divide by 2, so the sine of x over 2 is negative radical 3 over 2. Quadrants, when is sine negative? Reference angle, when is sine radical 3 over 2? So my angle, x over 2, could equal 60 degrees in quadrant 3, so 180 plus 60. And quadrant 4, 360 minus 60 is 300. We don't have double solutions on this one. Basically what that x over 2 means is we only get half of our sine graph. If I'm trying to solve for x, we multiply everything by 2. So we get 480 degrees and 600 degrees. But my directions said give me the solutions between 0 and 360. Neither one of those are between 0 and 360, so our answer is actually no solution. Okay, if you think about that, the graph of sine looks like this. Okay, this one would have a period of 2 pi divided by 1/2 or 4 pi. So it's 4 pi before we get all the way to the end. So at 2 pi, which is like 360, we've only had the positive half of the graph. We haven't seen any of the negatives yet. So that's why we did not have any solutions on that particular interval. Now if I had said give me all solutions, then we would have to keep those. Do you guys understand the difference there? Problem 13. Okay, so again, my angle is theta over 2. So I know that I'm only getting half of my graph, so I might have answers that I have to throw out at the end. If I am trying to solve this, we have an issue. What's wrong? Right, we have secant and we have tangent. We need one trig function. So grab your flip charts. Sarah, do you have your flip chart? So which tab am I going to look at here? Yeah, the basic identities tab. And what does it tell us about secant squared?
Equals tangent squared plus 1.
So we could replace that with tangent squared theta over 2 plus 1. Okay, so we still have something squared, but at least it's one trig function now. So if we kind of reorder this, this is tangent squared theta over 2 minus tangent theta over 2. If I subtract over my 3, 1 minus 3 is negative 2. So now I can do box method. Tangent squared would just break into tangent multiply to negative 2 and add to negative 1. So if we set those equal to 0, alright, we have to solve each of these. When is tangent positive? Reference angle. When is tangent 2? It's not one we know, so we have to go to the calculator. Switch it into degree mode. And then do tangent inverse of positive 2. So we get 63.43 degrees. So our angle, theta over 2, could equal, in quadrant 1, that would be 63.43 degrees. In quadrant 3, what would you have to do?
180 plus.
So we get 43.43 degrees. Okay, over here, if tangent is negative, that could be in 2 or 4. Reference angle, we know when tangent is 1. That happens at 45 degrees. So 45 in quadrant 2, so 180 minus 45 is 135. In quadrant 4, 360 minus 45 is 315. Now what do we need to do? Take everything times 2. to solve for my theta. So I get 126.86 degrees, 486.86 degrees, 270, and 630. But my directions were to give the answers between 0 and 360. So between 0 and 360, only these two work. Is this getting better as we go through it? Are you figuring out where you went wrong? If you went wrong? Any questions that are coming up so far? Yes.
So the only time that you have to like worry about different quadrants and stuff is in section 6.1 when you did the inverses.
When you're only using half the circle, yes. Now on the rest of these, we write out our quadrants, but it's based on it, you know, if it's positive or negative.
Okay.
So it's only if the original problem has an inverse that you're only dealing with two quadrants, and you only get one answer at the end. All right, number 14. So we're still solving equations, but I switched us over to radians here. Alright, so if I set this equal to 0, we have 2 cosine squared x minus 3 cosine x plus 1. So we can't just combine those, they're not like terms. But what we can do is box method. We have to do the full box method because my leading coefficient is a 2, not a 1. So if we set that up, so I need two things that multiply to 2 and add to negative 3. It would be a negative 2, negative 1. So then if we factor, we get 2 cosine x minus 1 and cosine x minus 1. If we set each of those equal to 0, then we get that cosine x is 1/2 and positive 1. Quadrants, when is cosine positive? Reference angle, we are in radians, when is cosine 1/2? 60 degrees is pi over 3. So my angle x could equal, in quadrant 1, pi over 3 is pi over 3. In quadrant 4, double minus 1 is 5 pi over 3. If cosine x equals positive 1, that only happens where? Cosine's positive when 1 and 4, but if we're looking when cosine is 1, that's just when x is 1, which only happens at 0. Which is technically the same as 2 pi, but my directions had the bracket on the 0, so I'll use it. Okay. Questions here? Number 15. What's wrong with this one? We have both cosine and sine, and we also have what? One of them has a 2x. So we have to rewrite this so that the angles are the same. So look at your flip chart. Since we have a cosine 2x, you want to go to the double angles. And what can I replace cosine 2x with? So you have three options. We picked this one because my other trig function is a sine. So now this is like a quadratic, so we need to set it equal to 0. I like my square term to be positive, so I'm going to add that over and subtract my 1. So now we can factor. Again, because this is a 2 for the coefficient, we have to do the full box. So I need two things that multiply to -2, add to +1. So that would be a +2 and a -1. So this factors into 2 sine x minus 1 and sine x plus 1. Okay. Two things multiply that equal 0, so you set each of those equal to 0. So we get sine to be a +1/2 or a -1. When is sine positive?
1 or 2.
Reference angle. When is sine 1/2? 5 or 6 at 30 degrees. So my angle x could equal, in quadrant 1, pi over 6 is pi over 6. In quadrant 2, it's 1 less, so 5 pi over 6. Sine x equals -1. So that's like on your unit circle asking when y is -1, which is where? 3 pi over 2. All right. Is that okay? Couple more. So what do we need to do here? Add over the sine 3x. Divide by 2. So then I have sine equal to a negative. So quadrants. When is sine negative? Reference angle. When does sine equal radical 2 over 2? So that's pi over 4. So we have 3x equals. In quadrant 3, pi over 4 would be 5 pi over 4. In quadrant 4, that's 7 pi over 4. What does the 3x tell me? Triple the solutions. So we need 4 more. How do we get them? So 2 pi, that's 8 over 4. So we get 13 pi over 4, 21 pi over 4, 15 pi over 4, and 23 pi over 4. Okay, so then to finish it, we have to divide every one of those by 3, or you could think of it as multiplying by 1/3. So 5 pi over 12, 7 pi over 12, 13 pi over 12, 15 pi over 12, which reduces to 5 pi over 4, 21 pi over 12, so that's 7 pi over 4, and 23 pi over 12. So you have to watch when you have double or triple solutions. Alright. Last. Okay, so I already have my trig function by itself. When you see that 2x, what does that mean? Okay, quadrants, when is sign positive? Reference angle, do we know when sine is 1/4? No, so we have to use our calculator. And we are in radians, so switch your mode into radians. Then we need to do sine inverse of 1/4. We get 0.253. So my angle, 2x, could equal, in quadrant 1, your reference angle and angle are the same. In quadrant 2, we normally do 180 minus, but we're in radians, so pi minus 0.253. And that gives me 2.889. But we said double solutions, so we need to get 2 more. What do I do to get that? Add 2 pi. So 2 pi plus 0.253. And 2 pi plus 2.889. So then, to get all of our answers, what do? Every one of those divided by 2. Work is important here because depending on how many decimals you kept, your answers might be slightly different. So as long as I have the work, then you're okay. It would only be the last decimal place that might be different, but just make sure you're showing me where your answers come from.